Hello everybody, this is Rochan here. Welcome to Learn with Rochan. This is the video of Amines chapter part 2. In the first video, we had discussed about introduction of amines and 4 reactions by which we can prepare amines. So from here we'll continue with the 5th and 6th reaction of preparation, some physical properties and chemical nature of amines. So those of you who haven't watched my previous video, please find the link in the description and do watch it. Like, share and subscribe. So here we will go with the 5th way of preparing amines that is very important for competitive or for boards, that is Gabriel Pthalimide synthesis of aliphatic amines. This is important. Only aliphatic amines can be prepared in this process. Why? Let us look into it after we learn the reaction. Now in this reaction, we will consider a compound which has benzene, C double bond O, C double bond O, NH. This is called phthalimide. As the name suggests, this phthalimide we are going to use and we are going to prepare aliphatic amines, right? So in the first step, what are we going to do? We are going to add alcoholic KOH. What is going to happen? Here substitution takes place, right? So there is, see, this is actually neutralization reaction which is going to take place. KOH is a base and this is slightly acidic. Phthalimide is acidic, so there is neutralization. What should be formed after neutralization? Of course, acid plus base will give you salt and water. So here let us show the salt. What is the salt which is formed? C double bond O, C double bond O. Of course, this will be N and K. So potassium is going to be responsible in forming the salt. Sorry, N minus and K plus. What is this called? This is called potassium salt of phthalimide. Simple. After this, the next step, we are going to add haloalkanes. Okay, remember here R cannot be an aryl group. Why cannot it be an aryl group? We'll come to it again. So what is the product formed when you add RX to potassium salt of phthalimide? Benzene, C double bond O, C double bond O. Here what happens is this whole thing acts as a nucleophile. Okay, so this is slightly positive, this is slightly negative here, delta positive and delta negative. So this positive part will come and attach to this. K will go out with X. This is what actually happens. So NR and you will be KX will go out. If you want, you can show it there. Right now, what is this particular compound called as? Of course, there is substitution of alkyl group, not aryl group. So here, N-alkyl substituted phthalimide. Or instead of writing substituted, we can just write N-alkyl, sorry. We can just write N-alkyl phthalimide, not a problem. Now, here in this step, we will get to know why aryl, if you take in place of R, if you take aryl, why there is no reaction going to happen? Now, we all know that from the chapter haloalkanes and haloarenes, if you have studied, that benzene ring, of course, benzene ring is going to have much of electron density. Why? Because there is delocalization of pi electrons. Why there is delocalization of pi electrons? Of course, this is going to show something called resonance. So in benzene, so benzene is resonance stabilized. As a result, electron rich benzene is going to be. Okay. Now if you take again here, if you take aryl, that is if you take benzene ring with C6H5, if you take, even here there is going to be resonance stability. Even this is going to be electron rich, right? So this electron rich will come in contact with electron rich, so there is repulsion, there is no attraction at all. So what is the reason that why aromatic amines cannot be prepared by Gabriel Pthalimide synthesis is that in the second step of substitution, what substitution? Nucleophilic substitution. Aryl halides, okay, they are not reactive towards nucleophilic substitution because this is also electron rich and phthalimide is also electron rich. That is why there is no aryl substitution in this case, and final product whatever we get, it is going to be aliphatic amine, right? So now from here what is going to happen? N-alkyl phthalimide is there. For this I am going to add aqueous KOH, or KOH also you can add, or NaOH. As per NCERT it is NaOH. What is going to form? Something called, this is of course there, C double bond O, C double bond O. With this you are going to get O minus Na plus, O minus Na plus. And what is this whole reaction we are doing is for what purpose? It is to get amines. So finally we will arrive at primary amine, of course aliphatic, right? So here let me just specify this first reaction is going to be neutralization reaction. Second reaction is going to be nucleophilic substitution. And the third subreaction is going to be hydrolysis. You are doing hydrolysis here. So this is the overall view of Gabriel Pthalimide synthesis. All three sub-reactions are very important, and this is how primary amines and aliphatic amines are prepared through Gabriel Pthalimide synthesis. So this is the fifth reaction we are seeing. I hope it is clear. With that, moving to the sixth reaction. It is called Hoffmann's broamide degradation reaction. Hoffmann's broamide degradation reaction. So as the name suggests, bro. So bro means bromine should be there. That is how you can remember the reaction. Now amides. In the fourth reaction we have studied about amines. Amides. It is RCONH2. This is going to be amide. So from the name itself you can guess the reactants. So they are going to be amide and you will have bromine. With this you have to remember one more compound, okay, that is nothing but NaOH. You can use aqueous or alcoholic, not a problem. So this is the reagent part, very simple from the name itself, broamide. So there is degradation of amide, that it will break down into simpler compounds. What will it break down into? Of course, what do we need? We need amines. That is we are studying this under preparation of amines. So amines will be formed. Now here you will have byproducts. Na and Br is there. So NaBr will be formed. Here you have CO. So related to CO, how will CO go out in this reaction? It will go out as carbonate. What carbonate can it form? Of course, sodium, Na2CO3. Now of course aqueous is there, so water will be there. Balancing the reaction in organic reactions, for both purpose balancing is not required, but in case we need to balance this reaction, for 1 mole of bromine we will need 4 NaOH to get 2 NaBr and 2 H2O. This will be the reaction. So very simple, and main important thing to note in this reaction. If you see here R, if I take CH3 C double bond O NH2 plus Br2 plus NaOH, what will I get? In place of R I have CH3 NH2 and I'll get NaBr, Na2CO3 and H2O. Observing one thing here you have 2 carbon. What is this compound called? It is called ethanamide. Meth, eth, 2 carbon. What is this called? Methanamine. Methanamine. So what is actually happening? Ethanamide is converted into methanamine. So very importantly, here in the reaction, whatever amide you would have taken, that will become into one lesser carbon and it will give you respective amine. If you take propanamide here, propanamide, you will get ethanamine. Ethanamine. So here this will be of one less carbon. Very important to note. So with this knowledge you can write the backward reaction also and forward reaction also. If you have methanamine, then from what it is prepared? It is prepared from ethanamide. If they ask with respect to Hoffmann's broamide degradation reaction. Very simple, I guess this was. So Hoffmann's broamide, bromine amide with NaOH. Of course, you will get RNH2, that is the amine. And with that, you will get NaBr. CO is there, it will go as carbonate Na2CO3, and aqueous is there, so H2O will come out. So these are the 2 reactions which we learned today. So for today, let us stop here. From the next session, let us, so here the for the preparation of amines is done.